Welcome to today's webinar. The topic today is glass design with Dlubal Software. My name is Andreas Hörold. I'm responsible for marketing and public relations in the Dlubal Software company. For instance, the Dlubal website, the press releases, the German and English webinars, etc. I will be the presenter today. My colleague Ulrich Lex will support me. He's responsible for the RFEM add-on module of glass and for the quality assurance of the main program RFEM. He will answer your questions. You can ask questions via the control panel on the right side of your screen. You can enter the question here. Ulrich will answer you. If you don't get an answer during the webinar because there are too many, you will get an email after the webinar. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. I turn off my webcam that you can see the full screen. To the agenda today. At first I will introduce some features of the add-on module of glass. Then I design a glass railing with the help of RFEM and add-on module of glass, and then a curved insulated glass pane. So I start with the features of glass. It's possible to design single layer laminated and insulating glass, also curved glass. In the second example, I will combine curved glass and insulating glass. You can consider the influence of the surrounding structure. I won't do that in this webinar. We did it in a previous webinar. That is a link here. If you want or if you have got interest in this webinar, point-supported glass with the steel structure here, you can click on the link when you downloaded the PowerPoint slide. Where you can find the PowerPoint slide, I will show you at the end of the webinar. So you can consider shear coupling of layers, climatic loads, for example, etc. And it's possible to do a stress analysis, the ultimate limit state design, and the serviceability limit state design. You can design independent from a code or with a code. So then we turn to the program. I start with a new model here, left above, new model. I call it glass railing. Then I want that the program RFEM creates the combinations automatically. According to DIN in that case, I would like to design according to the DIN 18008. If you want to design according to another international standard, then use here another standard for the combinations, for example the Eurocode 0. Okay, that's all for the dialogue. I changed the work plane here right above, XZ, and the view in -y direction. So then I create the rectangular plate. The material and the thickness doesn't matter. It will be overwritten by RF glass. Only the dimensions are important. Okay, 1 by 1 meters. Then I copy that line here in -z direction, 10 centimeters. Later I will define line supports on that line and that's why we get restrained in that area here. Okay, the dimensions are okay. Then I create new load cases. I start with the load case sales weight. Permanent is the action category. Sales weight is active, it's okay. Then the next load case, beam load. Yeah, imposed category it is okay. And the next load case, wind. Action category wind. Yeah, and that's okay. Only 3 load cases, 3 actions. Then here the combination expressions, 1 for the ultimate limit state, 3 for the serviceability limit state, action combinations, and the load combinations have been created, 5 for the ultimate limit state and the rest for the serviceability limit state. So, and all of them combined in 4 result combinations. ULS SLS 3 times. Okay. That's all. Now we need to define the beam load and the wind load. Start with the beam load, the new line load in Y direction, 0.5 kilonewton per meter. Here, and the wind load, the surface load in Y direction as well, and 0.85 kilonewton per square meter. Okay, that's all for RFEM. We created the model and the load cases and 2 loads. And now we open that on module here under others of class. All surfaces, we've got only 1 surface. I would like to design according to the DIN code. And yeah, it's possible to design independent of a code. Then the existing stresses will be compared with the limit stresses. Okay, then I select the result combination number 1 for the ultimate limit state design. For the serviceability limit state design, yeah, it's not necessary to design the serviceability limit state according to the DIN. It's not required for railings fixed on one side according to that code. Calculation type is local. We don't want to consider the whole structure in RFEM. We don't have any supporting structure. We use the local individual glass surface type. Then next dialog, the layers. For surface number 1, I start with the first layer, glass. I open the material library. Now there are a lot of glass types or materials. I use more than 1 in our webinar. I start in this, for this example, with the thermally toughened float glass. And 10 centimeters is okay, thermally toughened and laminated safety glass. Then next layer is the foil. I open the material library again and I use this one, PVB long time loading foil. Okay, the thickness is 1.52 millimeters and the next glass pane. Okay, that's all. the minimum requirements for an impact-resistant pane are fulfilled. Therefore, no pendulum impact test is required. We can, no, we don't have to leave the dialog. I need to edit the composition details. Yeah, it's possible to save created temporary models. I don't do that in this example, but in the second example. I don't consider coupling. According to Dean, it's not allowed to consider shear coupling. Yeah, but for other international standards, it's possible to consider shear coupling. So then I forgot, yeah, I would like to activate the FE mesh refinement of 5 centimeters. Yeah, and the rest is okay. So then the next dialog, line supports. I start with the first line, the bottom, okay. And I would like to support in all 3 directions. As you can see here, there are several support types, hinged types and rigid, and I use the user-defined type, not around Z direction, but in X, Y, Z, but with a spring constant of 10,000 kilonewton per square meter. Yeah, that depends on the elastic support, for example, by the elastomer. Okay, so that's all for the first line. Then the next line, this one, and I would like to consider a horizontal support. So that's why I showed the support axis system, and I would like to consider support in Z direction. The same spring. Okay. That's all for the line supports. Next dialog is nodal supports. Now, I don't want to consider a nodal support in that example. I will do that in the second example. So then boundary members. Yeah, it's possible to consider boundary members. For example, a handrail here. I don't do that. Load duration. Yeah, it's also the table is filled automatically. So then we can start the calculation. So a design ratio of 34%. Let's take a look at the graphic. Yeah, and as you can see, the maximum ratio and the maximum stresses are in that area here, in the area of the restraint. Okay, we can print that in the printout report. Full page width and 50% of the height. It's okay. So you can see the graphic here, but I would like to start with the general data of our class. Here above, the standard, the result combination, details, the data of the standard. Important here, the layers with the material parameters, the layer diagram, the line supports, the load duration, and the maximum stresses. Okay, that's all for this model. I create a new one, the ISO glass pane. Yeah, the same settings here. Okay, I change the view in Z direction. Then I change the grid by right click here at the bottom, edit to 25 centimeters. Okay. So then here left above an arc via edge nodes and radius. So first point and the second point by 1.5 meters. Okay. I reverse the orientation and enter the radius of 1.3 meters here. Okay, that's the arc. So, and now I copy that line here in -z direction and create a surface. So I select the line, then here move and or copy. One copy in -1.7 meters, and I added the expanded settings here at the bottom, and then I create surfaces between lines. Okay. That's a null surface, yeah, but it will be overwritten by half glass. So I divide that line here now. I would like to support in Z direction in the middle and near the corners here, by distance 20 centimeters, because I would like to avoid singularities here in the corners. Okay, then divide line by distance. Start 20 centimeters and 20 centimeters. Okay, and that nodes here I would like to support. So then the model is okay. I define the load cases. First the self-weight load case, then the wind. That's the right action category. Next load case, height difference. So I need to change the action category to changes in atmospheric pressure due to changes in altitude. So, and the third load case, climate. So, and then here actions from climate and temperature-induced constraints. So when I leave the dialog, I don't have to forget the wind load, but the load case is free, and 4 are placeholders to assign them in ARF class. So the same combination expressions, then the load combinations have been created automatically, and the 4 result combinations. So now I enter the wind load, surface load in local set direction 0.5 kilonewton per square meter. Okay. So that's all for RFEM. We can go in the add-on module. So phase number 1, same standard, and I select the combinations for the ultimate limit state design. It's not allowed to use result combinations for isolated glass because of the explicit classification of the climate loads. So serviceability limit state design is the same. The load combinations for the serviceability limit state design. Local calculation type again, and we can turn to the next dialog. The layers, phase number 1, and I start with the first layer, glass. This time heat strengthened float glass with a thickness of 6 millimeters, firmly toughened and laminated safety glass. So then a foil. This one is okay, but I changed the thickness. So next glass layer. Okay, and then the gas. Dry air is okay, but I would like to show you the material library. Dry air, but you can also use, for example, argon or krypton, etc. So thickness 16 millimeters. Then the glass in the middle. Float glass this time. 3 millimeters. And I can uncheck this. Then dry air is gas. Next glass layer. Heat strengthened float glass. The foil. And the last layer, the glass pane. Okay, let me check the entries. Here's the wrong thickness, 6 and 6. Okay. In the graphic you can see the single layers, glass, foil, glass, dry air as gas, glass, dry air, glass, foil and glass. Okay, let me check the composition details. As I promised, now I save the created temporary models. I don't consider coupling again. I activate FE mesh refinement and I can deselect this. The rest is quite okay. Then next dialog, line supports. I would like to support all lines in horizontal direction. I select here user defined. In Z direction I would like to support. So and we need to define this 3 times for this packet on the outside, in the middle and inside. Okay, that's all. Next dialog, the nodal supports. I would like to support the structure or the class pane in vertical direction in these points here. So I select the first 2 points. This one and this one. User defined. In local set direction. Okay, and the support in the middle here. Okay, user defined as well, and I would like to support in X and Z direction. Okay, that's all. Next dialog, boundary members. Yeah, I don't consider boundary members, but we need to define the climatic load parameters. The default values according to the standard are present. If you want to design according to another standard and you need to then you need to modify the entries here. I only need to assign the correct load cases here. Load case number 4 and here load case number 3. Okay, the same for the winter. Load case number 4, 2 times and 1 time. Load case number 3. So that's all for this dialog. Next dialog, insulating glass unit. You can consider secondaries here. I don't do that in this webinar. Maybe some words here to this area or this table. Self-weight and climatic loads are automatically assigned in the right place. But however, if wind suction acts, in addition to wind pressure, you have to define the load component here. You need to modify this value and this value. We have got only pressure from the outside, and that is why it is okay here. The load duration class is assigned automatically. Last dialog, the serviceability data, list of surfaces, surface number 1. Not the minimum boundary line. I select user defined and I measure the distance 1.5 meters. Okay, the entries are complete. I would like to skip the calculation time and open a already calculated model. I've got a maximum ratio of 92%. Let's take a look at the maximum displacements. Maximum design ratio of 14%. The glass pane is quite stiff. So let's search for the maximum design ratio here, sigma x, and we open it in RFEM. As you can see here on the left side, the load combination 5, winter, has got the maximum stress and the maximum design ratio here at the top and at the bottom here, the area in layer number 1. Now we can open the printout report again. Now where are more data now? Should take some seconds. Might take quite long, maybe through the GoToWebinar software. So, okay. Now let's start here with the input data, the full width, general data with the combinations, the details, data for standard, the single layers with the material parameters, important are also the layer diagrams, the line and nodal supports, the climatic loads, all is integrated in the printout report. And here the graphic. Okay. I would like to show you the temporary model, one of the temporary models. Yeah, as you can see, it's quite detailed. You can see the glass panes here, the solids, the gas solids, the single supports, line supports, the nodal supports. Here are line hinges. And now the two load cases 3 and 4 has got loads. The surface load, then the load case number 4 has got the surface loads, and here the solid loads. And RF Glass uses these temporary models in the background for its calculation. And if you check to show or to create the models, then you will see it in the same folder of your model. Okay, that's all to this example. I'm finished with the presentation. Before I show you where you can find the recording and the models and the slides, I would like to introduce our free online services. For example, our GeoZone tool with the snow, wind and seismic zone maps, the cross-section properties, where you can also define parameterized cross-sections and calculate its cross-section properties, the FAQs and knowledge base, a lot of valuable articles. You can use the search function to find your article or the article that you need. The models to download, there are more than 1,000 models to download. For example, to help you to get started or for your project. A lot of RFEM, RSTARP, RWind models, etc. Then our free YouTube channel with the recorded webinars and a lot of valuable videos. Our web shop is with prices. We are quite open with our prices. Then just download the trial version of RFEM, RSTARP, RWind simulation, Craneway, ARX Timber, off buckling, etc. if you haven't already registered for our newsletter, just register, and then you will get the information about free webinars, videos, news from our software, etc. So then we go to the website. In the next days you will get an email with your certificate and with a link to that page here, news and events, webinars, and to today's webinar. So, and then you will find the recording here. Here you can find the presentation slides. I've already downloaded it here, and the two models. Okay, I switch on my webcam. Thank you for your attention. Thanks to Ulrich for answering your questions. I hope you enjoyed the webinar a little bit. Maybe we can see us later in our webinar. Maybe some hint when you close the webinar, where will be, you can score us. Just note that the worst score is 1 and the best score is 5. Would be very nice when you score us. Okay, that's all. Thank you and bye-bye. Have a nice day. Okay, bye.